Now, this was a 2-hour presentation he gave, so I'm going to give a lot more abbreviated version of it. But basically, storage tanks, as far as we're concerned, we're focusing on vertical above ground storage tanks. These are going to be holding petroleum products. I know a lot of people think, well, storage tank, it could hold wine and a lot of other things. For the sake of our tools and Realworks, we focus on petroleum products. It can be chemicals. It can be quite large. It can be 30 meters tall, up to 100 meters in diameter, potentially even bigger. But they can also be quite small, maybe only just a few meters in diameter. And there's thousands of them worldwide. If you look at the pictures on the right-hand side of the screen, these are common views that you'll see anytime you're traveling through the air. Look out your airplane screen. You see tank farms all over, especially by our ports or any place where you have a lot of oil and gas operations. Now, these tanks are complex. They can be pressurized, they can be insulated, they can be heated. You can have mixing systems for mixing the product inside. They can have floating roof. I know that sounds weird, but if you look in the upper right-hand corner, you'll notice this one tank here that kind of looks weird. That's a floating roof, so the roof moves up and down with the product. They can be double floored, they can be double walled. Double walled sounds just like it. It's just like double pane windows. They can be vented, they can be lined, they can have all kinds of corrosion preventative systems. And most of them will have what we call a secondary containment system. And again, if you look in the upper right-hand picture, you'll see these kind of dirt walls built around these tanks. These can be dirt, they can be concrete many times. These are built in case the storage tank leaks, and you don't want that to get out from the area. Now, with storage tanks, we do a lot of inspection, and the reason is because the tanks are always falling apart, just like people. They're corroding. This can be due to wind or weather, it could be seismic activity, or just the settlement. I know around here, we have a shopping mall close by, and it seems like every time I visit it, they're tearing down another store because the ground is moving and it's destroying the buildings. Same thing can happen to storage tanks. They can settle in and start to have problems. Another problem they can have can be impacts, just trucks or any other pieces of equipment running into them. You can overfill or underfill, causing them to collapse or to explode. In fact, we recently had a mystery here in Colorado where we heard a loud boom and nobody knew what the boom was from. And the leading theory is that it was due to a storage tank close by actually exploding from pressurization. So that leads us to storage tank inspection. So regular inspection reduces the chances of major problems. And certainly maintenance is a lot less expensive than replacing a tank and all of the product inside it and all of the ill will from having something like this where you have an environmental disaster. So the tanks, they're inspected regularly. There's different standards for different regions around the world. A couple of the big ones are API. This is the American Petroleum Institute. Certainly covers most of the US. There's a lot of countries that have adopted it. Also, we have the ISO standards, very similar to API. In fact, the two groups will mirror each other on writing their standards. So if one writes a standard first, the other one will pretty much follow along. There's also other standards such as the STI, the PTB in Germany, and then many, many countries have their own variations and localized standards. Now, with our software, I'll just tell you now while we're talking about the standards, we follow the standards as close as we can. We're not certified by any of these organizations. In fact, these organizations don't certify any manufacturer. What they do is write procedures, like how to do your survey, to check the temperature, to check the instrument, make sure that it's been calibrated, these types of things. So when people say, oh, is your software certified by such and such? No, and it won't be because these standard organizations don't do that. I don't know, might have some small country that might accept some money to do something like that, but we're probably not going to do that. So as far as the standards go, there also are no standards written for laser scanning, at least that I know of yet. The standards are written for using standard tape measures that you pull to a certain tension, total stations, and various instruments that have been made specific to the storage tank industry. The standards are more rigid on what we call calibration or doing volume. So we actually don't chase that as much because the standards actually do tell you to use a total station specifically. Now, on the inspection side, the standards are a lot more lenient. They don't care what instruments you measure. They just tell you what you should measure and how to go about measuring it. So that's why we have a lot more inspection tools inside of Realworks than we do for volume calibration. Anyway, so I think I've covered this. There are regular inspections that need to be done on these to check corrosion, depending on the kind of material and environmental risks. So these types of inspections can be routine in-service inspection. This means while the tank has product in it. These are usually going by, doing visual checks, looking for leaks, signs of corrosion, or any kind of obvious distortions that may require the tank to go out of service for a more rigid inspection. Now with the laser scanning, you can certainly scan the outside of the tanks while they're in service, and you can get a fair amount of information. You can look for deformation in the tank. If you can dig down and find to where the tank connects to its foundation, then you can also kind of do a bottom or edge settlement. But it's usually better to do these kinds of surveys from the inside of the tank when they're out of service. So on the inspection types, the external inspection is generally once about 5 years by a certified inspector. So with API here in the US, other regions are similar. You have to have a certified inspector. You can't just hire anybody to do this. But I do notice that there seem to be a lot of companies in the US that will just pop up out of nowhere. So I don't know how stringent it is to become a certified inspector, but there are a lot of companies doing this. It requires visual inspection of exterior, could involve removal of coatings and insulation to check for more corrosion. Inspection types also have internal inspections. That's what I was talking about. These are usually once every 10 years, again, by a certified inspector. The companies usually don't like to do these as much because it means they have to take the product out of the storage tank. And when it's out of the tank, it's not making as much money as it could be. So they don't like to just take them out of service just for the heck of it. They really want to do these on some sort of a specific interval. These usually involve thorough inspection of all the internal structures and the roof system, also looking at the bottom and shell thickness and looking for any kind of pitting or settlement or deformation in the floor or the shell. And in case you're not sure with the terminology, I'll cover this a little bit later. The shell is basically the wall. What we're calling the bottom is the floor of the tank. And then inside, if you look at this picture on the right, you'll see these support structures, these I-beams here. Anything in the tank that's not the bottom or the shell that would tend to subtract from the volume of product in there is typically referred to as dead wood. Now, of course, this is the English term. I don't know what you'd call it in other languages, but that's what we call it. Now, this distortions and settlement reporting requirements. As far as the API, this is the standard 653, and there's appendixes to all of these. This is the evaluation of the tank bottle. So what they want to do is they want to look at the bottom of the tank. And if you can look at the screen up here, I'll show you a little bit on the tank. The bottom should be nice and flat. Well, imagine that's flat. You don't want a bottom that's looking wavy like this. So that's what they're going to be looking for. And similar to the picture that I've got on the screen, it's particularly important to pay attention to the outside edge of the tank. So where the shell is connecting to the floor. These shells are quite heavy. There's a lot of weight involved, and they push down on the floor. And what's really concerning is if this floor starts to bend at a sharp angle, they're worried that there can be cracking here causing the shell or causing the floor to leak. So in the picture that you see on the screen down here in the lower right, that's where you can see that bending down. And that's what we refer to as edge settlement. So this is particularly important. Edge settlement and bottom settlement of the tank. They're also looking for any kind of tilt in the tank if it's leaning one way or the other. And I think that's it for the floor settlement. Also on here, they're looking for any kind of distortions in the tank shell itself. So you can see on the picture on the right-hand side, we have these red vertical lines. Generally, they'll go around the outside of the tank. And if we look at this from a bird's eye view, they'll usually have what's called a manway on the tank. This is the entry point where people will go. Most companies will make their first inspection station right there at that manway. And then they'll find one directly across from it, and then they'll go in even intervals around the tank. So this would be something like station 1. Generally, they'll go clockwise or counterclockwise. We'll say counterclockwise, or we'll go clockwise to be easy. 1, 2, 3, 4, 5, 6, 7, 8. So there's always going to be an even number of these inspection stations going around the tank. Now, the number of these depend on which standard you're following and the diameter of the tank. If it's a larger diameter tank, then they're going to require more of these inspection stations. And also, different customers may want to, tank owner operators, when I say customers, may want a more thorough inspection of their tank. So they may want more of these inspection stations, even though the standard might not require that. In fact, I've had people want almost an infinite amount of inspection stations around the tank. Now, as you see in the PowerPoint slide, these are generally evenly spaced. And let's see what else. Oh yeah, so as we go up the tank, we're going to be checking the roundness. So this is looking at the tank from the top down. So as we go around the tank, they're going to have these welds. So they build these tanks a bit like you would build a wedding cake. So there'll be a weld at the bottom. That will carried away with my drawing here. There'll be a weld at the bottom. This is generally called the shell to bottom weld. Then there'll be another weld going up here, another one here, and then you'll have a weld connecting the top of the tank to the shell. And of course, there'll be welds along here as they put these plates together to make the tank. So from one weld, one horizontal weld to the next horizontal weld is referred to a course. So this would be course 1, course 2, course 3 as you go up the tank. And as they go up through these courses, they want to check the roundness of the tank and make sure that it's not oval shaped anywhere. They're also going to be checking for buckling of the tank, looking for flat spots, and peaking and banding of welds. So these are deformation in the welds. So as they do this, going up the horizontal welds, you'll see in the picture here we have these yellow and blue lines on the screen. What these are is they're going to have inspection stations going up the tank. Now again, we're following API 653 for the most part. As you go up, they'll usually have an inspection position between each of these welds. So between the shell to bottom weld and the next weld, they'll put another inspection station. And then they'll put another one halfway between here, and then another one halfway here. And then typically, they'll want an inspection 20% or 1 foot or something above the bottom weld and below the next weld, and above the weld and below the weld, so on and so forth till you get to the top. And then they're going to compare those with those vertical lines we talked about, where we did station 1, 2, 3, 4, 5, 6, 7, and 8. And then they're going to look at the intersection of all of these lines. So again, this standard is written for total stations. And so this grid pattern is what they would do with a total station. And because that's what they're used to, that's what we do in Realworks by default. Once we've done that, then we'll actually go into our traditional inspection tools to look at the entire tank. But most owner operators won't let you even get there unless you show what they're already expecting with total stations. Now, laser scanning for inspections, it's got a lot of benefits. It's going to reduce fill time. So we can scan one of these tanks in a short amount of time, whereas a 2-man field team may take quite a bit of time using a tape, a traditional tape, a steel tape, or even using a total station. We're also going to have detailed, accurate data. Now, we don't claim to be any more accurate than traditional methods like a total station, but with laser scanning, you are certainly more thorough. So like I mentioned, the total station is going to check each of these grid points where these lines intersect. But what's happening in between these grid points? You don't know with a total station, and some of these areas can actually be quite large. So the laser scanning will actually allow you to see what's going on in between each of these grid points. And this has a lot of appeal to owner-operators. So in addition to being faster and easier for the field crew, it's safer, you're down on the ground, you're not having to do a lot of what they had to do in the past. It also gives a much more detailed report to the owner-operator, giving them a lot better idea of what's going on with their storage tank. And again, these tanks are very expensive. If they go down, it costs a lot of money. So companies are very interested to have this type of work. In fact, some of our customers that are doing storage tank inspection today, I've asked, why are you doing laser scanning? Is it because of the reduced field time or the safety aspect or the fact that you can send one person instead of two? And they said, to be truthful, most of their clients are requesting laser scanning data now, so they really don't have any choice. So in addition, we also provide easy visualization. It provides a complete settlement analysis, complete distortion analysis. And when I say complete, it's all encompassing, more thorough, as opposed to just hitting the grid points. And it allows for further analysis inside of the office to go through and really find out where the problems are and how bad they are. And if you were to do scans over time, you could even start to figure out rate of change. So that leads me to the Trimble Realworks Advanced Tank Edition. So this, like I mentioned, is going to provide a streamlined workflow to quickly produce the deliverables for tank inspections. Now, I know I'm talking a lot about inspections. That's our biggest market that we're going after. I will talk a little bit about the other tools as we go on through the presentation. So what we've done with the workflow, we noticed before we had the tank edition, you could still do a lot of this work in Realworks, but it was quite manual. It might take up to 5 days to create an inspection report. The biggest time-consuming parts were cleaning the data set to focus on the tank, to get rid of stairs and that dead wood we were talking about, and grass and vegetation and manways and nozzles. Just removing all of that sometimes could take 2 days, depending on the skill of the person using the software. Then you had to create the stations. This was time consuming. We're handling all of this automatically now. So what Realworks does, we've made the tools to follow the workflow that a traditional tank inspector would use, thinking more like a tank inspector as opposed to a surveyor or a laser scanning professional. So it allows you to configure those vertical stations. We define those courses very easily, just picking points. I'll show you here in just a second. We can define specific tolerances. Again, we're not conforming or forcing you to use one standard over the other. The software allows you to adhere to different standards because you can enter in your own tolerances. So this makes it appealing to people all around the world. Then we can automatically generate these reports with customized details and export for immediate delivery. Okay, just so I don't forget, the secondary containment analysis. Again, I mentioned earlier that these are walls or dikes or a kind of a dam wall that they build around the storage tank in case it leaks to hold all of the product. So these storage tanks are made assuming that it's going to be raining a lot when the product leaks. So they need to hold a certain amount of rainwater, and they need to hold everything that the tank can hold. So what people will have to do is build these dike walls, do some quick surveying, do some calculation on the storage tank, and say, okay, it will hold 110% of the tank or 120% of the tank. So you can guess that this is not an exact science, right? You've got dirt that's got different shapes, a storage tank. What we've done with Realworks, we made it a lot easier to get fairly consistent results because we are creating a volume of the whole surface area. And we also calculate the volume of the tank and then subtract that from the volume of the secondary containment. So this will work with dirt walls or even straight up and down concrete walls as well. So then we can create a report similar to this. This is actually an older report. The new report's fairly similar. We don't put a screen snap in by default, but it's easy enough in Realworks to click the capture screen button and then paste that into the report to get something very nice looking. Tank calibration. So this was actually our original market for storage tanks. The reason being, when we bought the Calidus company, they made the Trimble CX. They had a market of storage tank volume calibration customers. Turns out that customer was the German PTB. They had actually created standards specifically for the CX or the Calidus scanner, and an old software they had called 3D Extractor. Now this is an interesting case where they actually did certify a manufacturer's product. It was certified only for that scanner and only for that software, and only for that scanner if it had gone through a secondary testing procedure to prove the calibration of the instrument. That instrument's gone away, that software's gone away. Right now, I'm not directly working with the PTB. I know we have some dealers that are talking to them to try to get the TX8 in there. But that's how we got started. Well, it turns out, because there weren't any other standards in the rest of the world, nobody else was that interested. They were actually really interested at first until we told them that there weren't any standards, and then they got a little bit nervous. There still aren't any standards, but the strange case is it's like the chicken and the egg. The standards don't get written until people actually start to do it. And we do have people around the world that are trying it now. They have different avenues. Some say, well, scanner's close to a total station. This isn't totally true, but if they can get away with it, great for them. Other people just say, our owner-operator understands that there's no standards for this, but they like the thoroughness of the volume calibration, and they're okay with that. I would say, though, that this isn't our biggest market, and if you do talk to a customer about using laser scanning and Realworks for the volume calibration, to make sure they have a good demo and understand how the software works before they commit to buying it, so that they're clear on how the process is working and what's going to be required. One big thing with our tool is we don't automatically remove dead wood from the volume. This was something that they would have to do manually, whether they used a laser scanner or not. But what they can do is take all of our sizing of the storage tank and put it into whatever software or spreadsheet they're currently using. So it does provide some benefit. It does provide more thorough coverage and gets them closer to what they would have to do manually. So these are just a little bit of the standards on inspection. There's the ISO 7507. For volumes, sorry, these are volumes. For the API, it's the Manual Petroleum Measurement Standards. This is chapter 2.2D that's covering that. This is the optical instrument ranging method, basically total stations. Okay, so let me open up the software. And again, if you have any questions, go ahead and type those in, and we'll take a look at those once we're done. To run you through a quick workflow, and I'm going to go very fast, but we'll have this video so you can go back and watch it later. But this is the workflow, and I will typically go through this with customers so they see how I'm doing an inspection and how the software works, and then they can ask any questions as we go. But for the most part, people are actually quite pleased when they see the product. So with the software, what we do is we select the point cloud, we make sure we're in the production tab, and you want to make sure that you have the advanced storage tank edition of Trimble Realworks so that you've got this tab up here. And what we start out with is a tank setup. So we go through there. Then we need to define how we're going to set this tank, what kind of tank this is. This is a vertical cylinder as opposed to a horizontal cylinder. The scans were all done inside. If you're not sure where they came from, just take a top view of your scans and turn on the stations and you can see where they are. And what kind of a bottom. So tanks can have different types of bottoms. This is a huge mess. The storage tanks can have just a flat bottom. It can be straight like that. It could be even a little bit sloped. Or they could also have what we call a cone up bottom that looks like that. Or they could have a cone down bottom. There's a couple of different ways that you can see these storage tanks built. I've actually even seen some stranger variations, but these are the most common that you'll see. So in the software, we have the choice from these three. This is in fact a flat bottom on this scan, or on this tank. Then we hit classify. And this is a special set of classifications specifically for storage tanks. And what this does is it will go through and isolate the different components of the tank. It'll look for the shell, the bottom, the roof. I feel like YMCA here. And it's doing all this automatically for you. So remember earlier when I said this could take up to 2 days, we just did this in about 15 seconds. Now, the software doesn't get everything perfect. So if I look over here, I can turn off different areas. So these are kind of red points are remaining. So quickly those are gone. I can hide the roof, this purple area up here. And then I'm left with the shell, the deadwood. I can get rid of that. You can see in here the yellow is the deadwood. Here's these heating pipes. There's also some mixers in here and different components. So I'm going to hide the deadwood for now. That leaves me with the shell and the bottom. So I'm going to go in and do some quick cleanup on here. I'm just going to click the edit button, brings up the segmentation tool. So this area up here on top, I'm just going to put my tank into a constrained view. It's going to lock the Z-axis so it's not wobbling back and forth as I work with it. So I'm just going to quickly go across here and fence around this area up here. This is all part of the roof. Now I don't want to use in or out right now. I could if I was going to do further cleaning, but for the most part, I'm just going to assign this to a specific type of object. So this is the roof. I'm going to pick roof, and I'm going to click on assign to that desired group. Then I'm going to come down here, I'm hiding the bottom, and I'm going to look around the bottom of the tank because that's where you'll usually see grass or vegetation or manways or nozzles. Now you might notice if I increase the pixel size here, there's a few stray points. I'm not going to worry about those few stray points. The software is really looking more for an average of the point cloud. So as I rotate around here, I'm going to look for nozzles. And again, I'm looking kind of in this area along the bottom. All right, so this looks like this is part of a nozzle here that the software didn't completely remove. So I'm just going to make that part of my remaining group. And keep on rotating around. There's another nozzle there. So these are where they're hooking pipes or hoses and things up to the tank. There'll be quite a few of these on the tank. And for the purpose of this video, I am going fairly quickly. What's that? I can see the manways coming up over here. Somewhere. Oh, there's manway. So these are those, what we call the manway. These are the entry points for getting in and out of the tank. Okay, so that looks pretty good. There's another manway over here. All right. All right, so once we've gone through and cleaned that up, then we can also check the bottom. Again, this is a critical component we'll be working on, so I'm just going to unlock this constraint. So this I know is part of the manway, so we're going to change that to remaining. This, however, looks like a part of the shell, so I'm just going to change that to shell. Oh, I forgot to click the button. Here's another part of the manway over here. Make that remaining. Okay. All right, we got a few stray points here. We'll just get rid of those remaining. Okay, so that's looking pretty good. Again, there's a few small points sticking out. We're not going to worry about those. Now be careful with the bottom because remember, it's kind of undulating like this. So you don't just want to take a straight line and cut it across there because there may in fact be a few points that are following that. Once we're done, we click create. And then we get this object down here called a tank. You can see I actually created a couple of those. And actually there's one I cleaned up a little better here, this tank. We'll use that. Once we've cleaned it up, if we look inside that folder, I'm just going to hide everything. We'll see the different components. So there's the shell, nice and cleaned up. Here's the deadwood. So this is all the remaining stuff in there. These are the pipes along the bottom. Over here's a mixer that goes through there. This is what we call the dipping plate. So the dipping plate's important for doing volumes. when they measure the volume of the tank, is also sometimes called the gauge point. When they measure the volume of a tank, they usually stick a stick or a rod in through the top, and there's a specific hole so that it'll hit this gauge point. So they're always measuring to the same point on the tank. So everything down here under the gauge point is typically called the thump, and then this from here up will all be the volume of the tank. Okay, so that's what's in the tank folder. You don't want to mess with the things in the folder, but you could copy them. I just did a Control-C, and you could paste them out here. So if you wanted to work with that point cloud, you could do it out here, a copy of the object, but you don't want to change things in the folder. And the reason is we select that folder and we go into our vertical tank inspection tool. And our vertical tank inspection tool is looking for those components inside of that folder. So now once we get into the inspection tool, we'll go in and we want to go and define a height where we're going to check our verticality on our tanks. Now you see why I'm doing this in front of the whiteboard. So with the tank, we want to check the verticality of this wall over here. So what we do is we're going to pick a height all the way across the tank. And at that height, we want to create a perfectly vertical line, just like this. And we want to compare the tank shell to that vertical line. And we want to do that at each of our stations. Remember the 1, 2, 3, 4, etc., going all the way around. So we want to do it at the same height, create a vertical line, and check it all around the tank. This is slightly different than we used to do in the software. We used to just create a best fit cylinder. But by doing that, we found out that we could introduce a little bit of, exaggeration of the error on the roundness. So a tank may actually show that it's more out of round than it really was because it was actually had a deviation in the verticality of the tank there. So that's why we've changed it in the recent version 10.4 to give you a much more accurate representation of what was going on. I think we're the only company really doing it like that. I think most of the other companies are kind of following our past lead, and they're still fitting a vertical cylinder and trying to do it that way. Okay, so I'm just going to define that height. A lot of companies have a set height that they do, maybe 4 meters, maybe something like that above the ground. So you can just pick a point, or you can type it in. You could even use your measurement tool if you wanted to measure up that height and see how high it is. So once we've got that, then we need to say, do we want to go clockwise or counterclockwise? And step 2, pretty simple. We'll just go clockwise. How we're numbering it, from 1, from 0, or just doing angles. Most people will do clockwise. Most people use numbering of 1. And then we need to define our grid. So we're going to click on Define Grid. And then we're just going to rotate this tank around so we can see those manways. And then for our very first vertical station, we can just click this button here. Now most companies will put it at the manway or someplace close to the manway. Now if we do it at the manway, that 20% above here, the bottom weld will show up in a hole here. So you may want to move that over and put it beside the manway if you want to avoid having a missed measurement there. But it's totally up to the companies how they want to do it. You can also notice that this line is actually pretty big. It's just because I've got my CAD display in my settings set to 10 pixels, so it's a little bit easier to see. Then I can also see the size of this tank up here in the upper right. So up here I can see that this is a 34-foot tank, about a 10-meter tank. And I know for that size of a tank, I need a minimum of 8 stations. So I'm going to type in 8. And now you can see those 8 stations going around the tank. So this tallest line is the first station. and then they go around at even intervals around the tank. Okay, so I'm also using this constrained view to lock me in here. It's a little bit easier to see. Next, I'm going to add welds. Now you want to be careful with the cloud rendering. You can see if I use something like grayscale, you can kind of see the welds. If I use just like scan color, very difficult. So pick a good rendering to make it easy to see the welds. Then we just need to click on the button that says add welds. I'm going to click on the shell to bottom weld, and I'm going to click on each of the welds going up the tank. All right. Now, if you have difficulty seeing the weld, sometimes these tanks are brand new, they're white, the weld beads may not be that big. What you might want to do is when you do your scan, if you're using a TX6 or a TX8, TX8s are probably a lot better for this, do a dense area scan, maybe someplace close to that manway. That way it's easier to see those welds and pick them out, because it can be difficult sometimes if you've scanned far away or not really dense to actually see those. Also, maybe if you're using an SX10, you may want to take images when you do this scan. That way you can see those welds in the station-based view with the SX10 images. Or if you use an external camera with the TX8. For picking out something small and detailed like these weld beads, I probably wouldn't rely totally on the internal camera in the TX8. But the density you can't beat, and that's definitely the way to go if you can. Now, once I've done picking the welds, I click Done. Now, these orange lines are the welds. These yellow lines are those inspection steps in between. So if I scroll down here a little bit, in step 4, you'll see these rules. So if I wipe these rules out, you'll see all the yellow lines disappear. By default, you'll usually always put 2 to divide each of these welds or these courses into 2. You can see there. And then above, unfortunately, right now we don't have an option to put in like a 20% or an 80%, so we just have a distance. So in this case, I'm just putting in 12 inches as we go up the tank. So this is above each weld and below each weld. So we're going to have 3 inspections for each course. Okay, now on the bottom measurement, this is a little bit interesting. Remember, I told you that the bottom of the tank was pretty concerning to customers. So now when we look at the bottom, okay, so the bottom of the tank, bird's eye view, we're really worried about the outside where the weight of the shell is pushing down on the tank. So what we're going to do is divide this tank into 2 zones. We're going to refer to this as the outer zone, and this is the inner zone. Outer, inner. Okay. Now with the outer zone, what we are going to do is we're going to start checking the tank going towards the middle. And what we want to do is we're going to check the bottom of the tank at pretty regular intervals in this outer zone, because that's where we're probably going to see any kind of deformation. Once we hit the zone marker, then we can start to do much larger intervals in our inspection. So that was what we've done in the software. We've gone through and we've defined the zone. You can see here my zone width I've set at 1.78 meters. And the outer zone step, we're doing at pretty small intervals. And then when we get to the inner zone step, we're doing much larger, closer to 1 meter intervals along here. Okay. So then I'm just going to click apply, and the software now is going to go and trying to move my windows around here so I can watch for questions. Okay. Okay, so the software's gone through now and it's calculated everything that it needs to create a report. It's created that grid structure. If I hide the point cloud, you can see on the screen now, we're going to have an inspection everywhere these blue vertical lines intersect with these yellow horizontal lines. And this is what you are going to be very similar to a traditional total station inspection report. Before I create my report, though, I'm going to do one thing. I'm going to go to step 3. I've got a slow connection. I'm going to turn off my webcam for a minute. I think. Webcam. Okay, I think I turned it off. Yes. Okay.